If you have a radar detector, especially a high-end radar detector, then chances are you've probably looked stuff up on YouTube about it and seen, different testers, and you've seen various tests done on these, and a lot of people are interested, like how do they compare with the other detectors? And so, like one test you probably noticed that no one does, I've never seen anyone do it other than myself, is the quick trigger at a distance test. And they do the quick trigger test, but if you've noticed, it's always up close. They never do it at a distance. So why is that? Well, the main reason is odds. I'll have to go over it in a different video to explain exactly why, but just know that if you're going to test one detector versus another one, it would have to be in the exact same spot, and even a fraction of a millimeter off could like completely screw up the results and make a detector that's actually more sensitive and better at it actually look worse against the other detector that's actually, not quite as good. So that's the main reason they don't do it. The other reason is like you can't really reliably do that, but or can you? Because there is a new method that I found, and if you know me, I build my own custom hardware. So I built something really cool, and I'll just go ahead and show you what it is. Okay, so I'm going to be using the V1 Gen 2 for this test, and this is the only high-end radar detector I've done this test with, and so I don't know how the Uniden or the Escorts perform in this test, so I'm not going to comment on it. But anyways, here's the setup. So right here is a PLL, and as you can see, it's set to 4337.5, and basically the output of this runs into the input of this, which is an 8 times multiplier. So whatever frequency you put in here, this times it by 8, and this is a good old WR28 waveguide, 26.5 to 40 gigahertz, although it does perform very well at 24.150. So I can test anywhere from about 24 gigahertz to 36. I can actually go higher than that with it. I can go up to 42 gigahertz with it. But for this test, that's irrelevant. So this is how I'm going to generate the precise frequencies. And also this is, as you can see, it did come on. I didn't mean to do that. But anyways, in the menu, I have pop. And you can set the precise time that you want to do your pop shot with. So you can go all the way down to 1 millisecond and as high as you want to go. So that's the setup. And like I said, both these are custom built. I built these myself. I designed them myself. And so I'll go ahead and show you this on the spectrum analyzer, and we can compare it to an actual radar signal. So you can see how close they are and what they actually look like on the spectrum analyzer. Okay, I've got the spectrum analyzer going. The way I'm running this is actually off of Blade RF, and basically the setup here, it goes PLL multiplier, and there's my PLL signal. And you'll notice this doesn't have an antenna. It's because I don't have another one of these. These are like $1,000 used. So anyways, it works pretty well there. We have the radar antenna from the Stalker Dual, and this is just the LO. Anyways, we'll fire it up and we'll take a look at the actual radar signal first on the spectrum analyzer, and then we also have the V1 here in the V1 app running. So I'll go ahead and turn it on so we know what frequency it is. Let it stabilize. It says 34,716. Okay, there it is. Off. Turn it back on. You can see the warm up from the gun diode. Anyways, now I'll turn on my PLL. So we'll match it to about 34,716. So 34,716 divided by 8 is 4339.5 megahertz. And so basically 34,716 is going to go into this mixer. You'll see it popped up here. And so I'll turn it on. So you can see it's right here. Now I'm going to move it around. You can see it's moving to the left, now the right. Now we'll turn on the radar. We'll see how they compare. So there's the radar. And so I move down a little bit. Now I'll move towards the radar. And I know you're curious, what would happen if they intersected? Well, that's why you should subscribe. I'll turn it off. And I'll turn this off. So as you can see, they are pretty comparable to one another in strength. Mine is actually a little weaker than this, because if I put this over there, it's a decent amount stronger. But they're fairly close. So that's what it actually looks like on the spectrum analyzer when you compare the signal from mine to the actual gun diode radar. If you notice, like on mine, it was way more stable. It's because it's actually phase locked. It's a phase locked loop is the source. And so it's not going to drift around like the gun diode would. And basically, the gun diode is going to sit there and drift around. So that's just way more stable. I can dial in the exact frequency and it'll never change. And what's cool about it is most people, never get the, equipment because it's so expensive to actually test this stuff. But since I built it myself, it's much, much cheaper. So I can actually show you what they look like on the spectrum analyzer. Now let's go ahead and take a look at the V1 and what all we can do with it. All right, so here's the V1. It's on. We got 4337.5, which translates to 34.7 gigahertz exactly. And there's the app. So I'm gonna go ahead and turn it on. As you can see, it's centered exactly at 34.7 gigahertz, which is rare to see. And basically, right here, I can control the strength, so I can turn it down, like so. I can turn it back up. So I have precise control. This is actually with the amplifier on. So if I turn the amplifier off, I have even more control. And then this controls a voltage controlled attenuator. I can dial it back even more precise. I get very precise with the bars. But anyways, we have it going. So I'm actually turn it up about right here. Now let me show you this pop functionality. Okay, so I've got it at 34708. So let me just show you where it's at on here. So you'll see it pop up right there. And if you keep an eye, I'll turn it back off. And then I'll demonstrate the pop functionality, and there it's off. Okay, so that's where it's at. Now on here, to go to the pop functionality, just hold, it goes to the menu, then you hit pop. And then there's a duration. Default, I have it set at 250 milliseconds. And so then you just hit start like this, and it does the pop. So here's what it looks like on the spectrum analyzer. You'll see it pop up right here. Here we go, 3, 2, 1. As you can see, it pops up. I actually clear this so you can see it better. So that max hold's not here. Here it goes. Okay, as you can see, it appears and then disappears at 250 milliseconds. And so that's the pop functionality. Now I can get out of this menu, exit. We're back to the main menu. And basically I can turn this on, and then I'll turn the power down some, like that. Exit that menu. And so as you can see, we're at 34708. So for each megahertz we change on here, since it gets times by 8, it's going to change 8 megahertz for every megahertz. Anyways, if I go up 1 megahertz, so 3339, now it's 16. I'll go up one more, 24, go up one more, 32. Another thing we can do is I have a more coarse, so I can change it back down a little bit. And then these coarse buttons will change. I think it's 50 megahertz, but watch this. So as you can see, you can even test out of tune guns. I'll change it again. 35.5, go up one more. 35.9, so I can go down. Go back to there. Go back to 34.7, detune. 34.3. Change it, 33.9. I can dial it back to 33.8 something, 820. So as you can see, and we can also do K-band. So as you can see, we can test any frequency that this radar detector will pick up except for X and KU band. So anyways, let me go ahead and show you how I do the pop test and what significance it has. Okay, so if I want finer control with this power so that I can precisely dial in the exact bars, I need to disable the amp, so I'll just press and hold this to get into the main menu, then go to amp enable, and then change it from on to off, and then exit. And now the power level, so it's at 5. I'll just set it 0, and I'll exit. And here's how I set up the radar detector. As you can see, it's about a ½ an inch away from the horn, and you might be originally like, whoa, that's way too strong. This thing gets incredibly weak. So, I mean, it gets so weak the V1 can't even detect it from that far away. So anyways, we're on standby here. Now I'll turn it on. And it is transmitting a frequency. And as you can see, the Valentine's not going off. So I'm going to go into the power level. Now the power goes 0 to 63. And like I said, for even finer control, I can dial it back very precisely with this potentiometer. And that controls a 30 dB attenuator. Anyways, I'll slowly turn it up and we'll see when we get a detection. This is how I set the baseline for the maximum distance quick trigger test. Basically what I do, my rotary encoder is a little messed up. I need a better rotary encoder. But I slowly turn it up. In the actual test, I did it slower than this, but I'm just kind of doing it fast because of the video. So I'll just slowly creep up until we get a very first initial detection. And I believe it starts detecting at 25. So usually if you stop and wait a little bit, sometimes it'll pick it out. Okay, we got the first detection. So you can see 34.7 even. And that just started detecting it. And so what I'll do to get the absolute maximum distance is you can see it disappeared there. And there it came back. But what we want to do is get a minimum 1 bar. Because the way I characterize this is, there's like 1, 2, 3, 4, 5, 6 bars. But what I want to see for the maximum distance is 1 bar consistently. I don't want it to like intermittently drop out like that. So I still need to increase it. And what I do is I increase it until it's consistent and it doesn't go away. And that's the first testing point. That's the, I consider that the absolute maximum distance. And then we can start testing the quick triggers. So, like I said, if you're out on a flat road, this is simulating like, 10, 15 miles. So basically, now if you want to do a pop test, as you can see, it turned off again, so we actually need to increase it a little more. You can set it to like 30. And then we'll exit. Now I'm going to turn it off. Now, I'm going to do a quick trigger test, and it's not going to detect this. I'd be very surprised. Because at the absolute maximum distance, it's not going to pick up a 250 millisecond burst. But just to demonstrate. As you can see, it messed it. And I accidentally went out of the menu. Anyways. Mess. Okay. So let's actually start going over some of the results. But before I do that, let me actually go to where it will actually detect. And this is very impressive, by the way. Let me go back to 4337, so 34.7 even. And let's see, I'm going to adjust the power. So I'm going to turn it back on. As you can see, it takes a little bit before it detects it because it's so weak. So we want to increase it until we get 2 bars, and then dial it back to where it's like at the top of 1 bar. And so this is where it really improves. So I'm going to just turn it up until we get to 2 bars. Okay, there's 2 bars. Now I'm going to dial it back. 1 more. Okay, so that's a maximum 1 bar, consistent. That's how I characterize it. And so I'm going to exit this. I'm going to turn it off. Now it's very important. At this point, you do not want to touch the radar detector at all. And also, you want to stand in the same spot and keep your finger right here, because even a small movement, it can kind of throw it off, especially if you move the detector. So you want everything as consistent as possible. And so it's off. We go back into the menu. And you've seen it. It was at 1 bar with a constant on. It's like the top of 1 bar. It's almost 2 bars. We'll go to pop. And here's 250 milliseconds. And so, okay. Now we'll go start. As you can see, it picked it up. And like I said, with consistently on, or constant on, it was at the top of 1 bar. That's like, you know, it could be like 10, 12 miles away if you're on a flat road. So it's actually picking up I call it a super fast quick trigger with the stalker guns. But it's actually picking it up every single time I found it. It used to never do this. I mean, it wouldn't even detect a 1 second before this update. But now it consistently gets, and I'll even turn it down to 200, which is the fastest the stalker guns can acquire a speed. So you have to have that instant on remote to do it, but it's like on off. So here we go. And boom, it nails it every time. And I tested this a lot, but I tested each bar until the fastest one was detected 100% of the time in most cases. Now, if we dial this back to 67 milliseconds, which is the mile per hour pop radar speed, you'll see what happens. So 67 milliseconds. All right, here we go. As you can, well, it didn't even go on. There it goes. As you can see, it missed it. Boom, miss, miss, miss. Oh, there it finally got one, which is pretty impressive. But it'll miss almost all of them at that level. So, okay, let's actually go over the results now. Now that you know how I tested it. So yeah, we do like a 1 bar minimum, like when it's consistently 1 bar at the furthest distance, and then a maximum 1 bar, a minimum 2 bar, maximum 2 bar, all the way up until 67 milliseconds can hit 100% of the time. All right, so now let's look at the results. And it took hours to test all this too. Okay, so here's the results. And as you can see, I took some notes on, like the settings that I had. I didn't put every single thing, but it was in all bogeys mode and the K-band. I basically just put all the settings like I would normally run it. So K-band, special, the BSM Plus is checked for K-band. XK and KA are all on full sensitivity, and they were also on. So that's how I normally run it. And basically at 33.8, as you can see, 0% on this one. But this is like an absolute minimum, and so it didn't detect anything 1 second or below. Like I said, usually when it's at 1 bar minimum, like absolute minimum, this is like your far out, 15-mile range on a flat road. But as soon as we move up to the 1 bar maximum, consistent. So basically, we dial in 2 bars and then pull it back a little bit to where it's like the top of 1 bar. As you can see, the 67 millisecond hits 20% of the time, and 200 milliseconds, which is the fastest that the stalker guns can get the speed. It nailed it with 100% of the time. So, like 10, 12 miles, you'll be able to get the super fast stalker quick triggers 100% of the time as far as this test. And then the 2 bar minimum consistent. Basically, what I did here, since this hit 100% of the time, there's not really any point to test it here and further on because it's going to hit. So we just tested the one that didn't hit 100% of the time, which is the 67 milliseconds. As you can see, right when it breaks to 2 bars, we get it about half the time. And then when it's almost to 3 bars, 60% of the time, so a slight increase. And then finally, once we hit a 3 bar minimum, we get it 100% of the time. So if you want to detect 33.8 pop 100% of the time, you're going to need about 3 bars minimum. And then we moved on to 34.7. As you can see, it did a little bit better on this frequency. Still these, these three, 0%. But if you look at the 500 millisecond, like the fast stalker mode, which is what it is, and that's what most cops use. And it's honestly the best remote, but 20% of the time at the very maximum range, which is very impressive. In 750 seconds, with that remote, it's like you turn it on, wait a split second, then turn it back off. It's about 750 milliseconds. A lot of cops tend to do that 60% of the time. And then finally, at 1 second, 70% of the time. And then the 1 bar max. Basically, the only one that didn't hit was 67 milliseconds. And, to be honest, 67 milliseconds doesn't really matter at this frequency, but I figured I'd test it anyways because I was just curious because Stalker doesn't have that 67 millisecond. Anyways, the 200 millisecond, so super fast Stalker instant on, quick trigger, 100% of the time on that one. And so we rose it up to 2 bars minimum, and basically, 67 millisecond was half, and then all these other ones hit 100% of the time. And so as you can see, once again with 34.7, it's just like 33.8. It took 3 bar minimum to get 100% of the 67 milliseconds. And then we went to 35.5. Pretty much the same thing. Didn't hit any of these. But the 500 millisecond, it hit 100%. Very impressive. And like I said, far out max range right there. And then, here's the other one. Still missed all the 67s, but it got all the 200s. And then finally 60%, 90%. Finally, once again, just like the other two, it hit 3 bar minimum, consistent to hit 100%. Then we switched to K-band now. There's something interesting with K-band. And you'll notice that these fast ones, like 200 and below, they don't hit very much on K-band. And they kind of do here. But it's kind of weird because I noticed as you increase the strength, it's like it purposefully cuts these off. As you can see, these quicker ones, because really with K-band, you don't really. I mean, you probably do have quick. You probably can do quick triggers, but I don't think there's a 67 milliseconds for K-band that I'm aware of. But probably the main reason it cuts these faster ones off like this is probably because that's a methodology that they use to filter out FMCW radars. Because basically, the way I think about it, and this is kind of like reverse engineering the V1's logic to a degree, but it looks like it purposefully cuts these fast ones off because, if a signal's only there for a split second or low milliseconds, then it's probably a sweeping signal because it's probably one of the filters, the way that the V1 filters out FMCWs is it wants to see a consistent signal for a minimum amount of time, and it seems like that minimum amount of time is probably like 100 milliseconds or so. But anyways, yeah, so like 250, 200 milliseconds, it did really well. But as you can see, when you start getting into these lower power levels, it didn't do quite as well as the KA band. So the other thing I tested, which is very interesting, and I can test with this thing. Let me come back here. It's the out of tune signal. So I tested a 34 455, which I've actually seen several times, like around that frequency. And so that's what's pretty cool about this little thing that I've built. But anyways, the gist of this is the quicker ones don't work near as well as in tune signals, but it's still pretty decent. So, 1 bar absolute maximum range. And by the way, this isn't really reflected on this, but it seems like with the out of tune ones, the range ain't quite as much as the in tune ones. But yeah, as you can see, these quicker ones, that's about like the normal ones. But uh, as you remember, like in the 33 8, 34 7, and 35 5, the 1 bar max, 200 milliseconds was hitting 100% of the time. As you can see, since these frequencies aren't really a priority, they're cut back. But we still got 100% detection on 500 milliseconds. And that's probably done on purpose because you don't want to waste a whole lot of time scanning out of tune, but you still want to cover it. So it would make sense that they'd kind of cut back on these reaction times. So there's all the results for that. As you can see, 67 millisecond never hit, I don't think, once with the out of tune. So as you can see, there's the results. Pretty interesting. I don't think anyone else has done these tests like this because, like I said, you'd have to build, the boards like that. There may be someone, but I suspect that Valentine Research probably has some device like that in their research lab. But it was really cool to do that test. And one thing I'm really excited about is the way that setup is. You can directly compare the sensitivity of one radar detector to another without actually having to go out and drive any at all. And you can very precisely tell exactly how much more sensitive one detector is, versus the other. I really want to and look forward to testing like the Uniden R7, R8 line, the Max 360s, Escorts, and maybe Redenzos. But I currently don't own any of those, so maybe I'll buy one and then test it and then maybe resell it on eBay or something. So, there you have it. It's a pretty interesting and new way to test. That radar detector tester is a prototype, and so as you can see, it was two separate parts. I want to build it all, on one board, and it'll probably be about the size of a radar detector. And I'm actually going to build the horn antenna because that horn antenna that's on there right now, that WR28 waveguide horn antenna, those brand new, like that brand new from Pasternak's, like $2,200, but I got it for like $1,000 used. So it's kind of too expensive. You also have to have like very expensive cable. So I'm actually going to design. I'm in the process of designing my own horn antenna, and I'm actually bolt that on there. So pretty cool. Hope you enjoyed the video. And if you want to see some more future cool stuff, or if you have a request for like a certain test you want to see, like with this, just let me know down in the comments, and I'll see you next time.